Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is reverse linked list 2. It sounds like there must be a reverse linked list 1, but it's not on the must-know list. So you don't have to know that one, but you have to know this one, reverse linked list 2. Okay, given the head of a singly linked list and two integers, left and right, where left is less than or equal to right, reverse the nodes of the list from position left to position right and return the reversed list. Okay, what does that mean? Well, so this one, for example, the input is a five element list, 1, 2, 3, 4, 5. The input is also left equals 2 and right equals 4. All right, it's worth noting at this point that they're using a one-indexed list. Java uses a zero-index list, so we have to account for that. But left is 2, right is 4. What they want you to do is to reverse everything from 2 to 4 and return the new list, which would be this. Okay. Other examples, that's probably too simple. Number of nodes in the list is n. N can be between 1 and 500. We don't have to, n can't be 0, so we don't have to check for that. Node val, it's not really important. And left and right are somewhere between 1 and n inclusive. Left can equal right, which is kind of an edge case. I mean, actually, left equaling 1 is a little bit of an edge case, but we can handle that. All right. Oh, wait a second. Oh, follow-up. Could you do it in one pass? I think what I have in mind would be considered one pass. So let's move this over here and give ourselves a little bit more room. All right, here's the list node. It has two properties, val, which is an int, and next, pointer to the next node. It's got an empty constructor. It's got a constructor that takes only a val, and it's got a constructor that takes a val and a pointer to the next node. All right. So there are some cases where we don't really have to do anything. For example, if the head pointer not next. Now they said it's at least the list is at least a length of 1, but if it's 1, we still can't really reverse it. So if head.next equals null, or if left equals right, which is a possibility, in both of those cases, just return the head pointer. There isn't anything we can do with that. Next thing we want to do is iterate through the list to find the left node. Well, actually, that's not quite right. We want to find the node before the left node. We need to keep a pointer to the node before the left node because we're going to reverse this subsequence of nodes in the list and then reattach it to the list. And the point that we need to reattach it to is we need to reattach it to the node before the first node that we used in the reversal process. It is possible that the first node, or it's possible that left will come in as 1. And so because of that, we need to say list node, call it node before reverse equals a new list node. The value doesn't really matter, but it needs to point to the head of the list. So this is kind of a dummy node that we may need. We would need it if the first node in the reversal sequence is 1. Other than that, we're going to iterate through the list and find the node before left. So let's say int I equals 0, I is less than left, and also because the challenge is using one indexed list, and Java has 0 indexed lists. So we have to find not just I is less than left, but I is less than left minus 1. Iterate through that, and each iteration will say, let me copy that instead of typing it, node before reverse equals node before reverse dot next. All right, so that will take us to the node before the first node that we want to reverse. So node for reverse, we're going to need that later. Next thing we need is the first node to reverse. This is essentially the left pointer. So let's say first reversed equals node, do I still have that? Oh yeah, node before reverse dot next. Okay. We're also going to need that later. We're going to need that pointer because once we reverse this segment, first reversed is going to point to the last node in the reversed segment. It starts out pointing to the first node. At the end, it's going to point to the last node. Well, we also need that because in reattaching it into the list, we are going to have to set the next pointer of first reversed so that we can reattach it into the list. All right, and then we need a couple of more pointers here that we're going to use for iteration. One we can call current, and current to start with is okay, yeah, that's fine. Is first reversed. We are going to need a node called previous. And previous, well, right now there is no previous. So we'll just set it to null. Next step is to go ahead and reverse all the pointers. So let's, let me think. We just need a count. We just need a count on this. So for, it doesn't need to be in parentheses, for int I equals 0, I is less than, so the length of the sequence that we need to reverse would be right minus left plus 1, right? So, you know, in the example, what are we reversing? We are reversing left is 2, right is 4. So that is 3 nodes. 4 minus 2 plus 1. 3 nodes. Okay. So I less than left, I'm sorry, right minus left plus 1. I plus plus. need a temp here. You know, when you swap things, well, in most languages, when you swap things, you need a temp variable to hold the thing that you're about to swap into. So in this case, we are going to put the current dot next into a temp. Okay, and then we are going to set current dot next to previous. We are going to then advance previous to current, and we're going to advance current to current dot, the current dot next, which we saved in next.temp. Okay, so let me try to illustrate what's going on here. So current, first reverse. Current will initially get set to, in this example, 2, the 2 node. Previous is no. So when we go into this, current.next is 3. So next temp becomes 3. Current.next is going to get set to no. That's fine because this node is going to be at the end of the reversed list. So that gets set to no. Previous will then get set to current. So previous becomes 2 and current goes to current.next and it becomes 3. So current is now 3. Next time through the loop, next temp will be current, which is now 3, current.next. So next temp will point to 4. Current.next will point to previous, which is now 2. So 3 is going to point back to 2. Previous will then get set to current, which is 3, and current will get set to next temp, which is now 4, and we'll continue in that manner. It's just reversing the pointers. So instead of 2 pointing to 3, 3 pointing to 4, what we're going to have at the end of this is 4 will point to 3, 3 will point to 2, 2 will point to no. 4 will be at the front of the list, and then we'll just reattach it. We'll reattach it in between 1 and 5. Okay. Okay, once we finish doing all this, we've completely messed up the list. But we can fix it. Node before reverse. Okay, so node before reverse is, in example 1, node before reverse points to node 1. So we can say node before reverse. I copied that at one point. Do I still have it? I do. Node before reverse dot next. Oh, another thing I should add here is by the time we get through looping through the reversal process, previous will be pointing to the 4 node and current will be pointed to the 5 node. Okay? So we can say node before reverse dot next equals previous. Previous is now the 4 node. So 1 is going to point to the 4 node, which is what we want. We can also say first reversed, which is pointing to the 2 node. We can say first reversed dot next equals current. Current is the 5 node. So we went through the loop and we pointed 4 to 3, you pointed 3 to 2, and now we can point 1 to 4, we can point 2 to 5. In return, I just realized I don't have what I want here. Because, all right, so, yeah, I did that and then I used it in the iteration. Okay, we gotta patch this up a little bit. This dummy node, let's make it a dummy node. All right, so it doesn't move. I don't want it to move. This is, we need this in case, as I said, in case the reversal sequence starts with node 1. We need something, we need a node before the reversal. All right, no equals dummy node. All right, and then what we're going to return is, dummy node dot next, which will point to the head of the list. Let's see, node before reversed. I mean, in this case, node before reverse would point to the head of the list also, but in cases where we started with the first node and started reversing from there, it wouldn't. So we have to have the extra node there. All right, I'm going to try and run this and see what happens. Compile error, can't find symbol. What is that? Current. Oh, yeah. You know, maybe I should be a little bit more consistent in the way I name things. All right. CURR. Did I use it again? Yes. Maybe I should have changed it to current in one place instead of changing it to CURR in like 6 places. All right, let's try it again. Accepted. All right, basic cases pass. Scoot this over a little bit and submit. All right, that's good. Runtime is 0. We should get more than that though. I mean, it should show it. Is it down here? Runtime. There are not enough accepted submissions to show data. That's weird. All right, analyze complexity. To me, it's it's O of n. It's just one pass. All right, good. That's it. I hope you enjoyed it. Please feel free to like, subscribe, comment, and see you next time.